This is the projectile motion introduction, and what you should have open is Notability or some other note-taking app in the background so that you can pause this video and take some notes on projectile motion. This is just a quick introduction to prepare you for class tomorrow. Okay, I want you to remember back to kinematics, 1D motion. If you have something like a car driving along at a constant speed like shown here, let's just say it's going 5 meters per second, you could easily figure out how many meters it's gone after a certain amount of time. So for example, if you have driven for just 1 second of time and this car is traveling 5 meters per second, how far has it gone? And clearly it has gone 5 meters in this little time interval from where it started. And then in the second of time, it has traveled another 5 meters of distance, which means the total distance that it has gone at that point is 10 meters. And then from the beginning all the way to the 3rd second, it's traveled another 5 meters of distance, which means its complete distance for that is 15 meters, and so on, 20 meters by the time it gets to 4 seconds. So constant speed in the x direction, nice and easy to figure out how far something has gone. The speed is not changing, it's 5 meters per second, so every second it's gaining another 5. Very simple and straightforward. And this is all happening in the x direction. Okay, I also want you to remember free fall, and that gravity will affect objects in the air, and it is going to either speed them up or slow them down at approximately 10 meters per second squared, which is 10 meters per second per second. What that means is for every 1 second of fall, you are going to gain or lose 10 meters per second of speed for each 1 second that the object is in the air. So for example, if I drop this ball after 1 second of time goes by, we can figure out how fast it's going. It would be going 10 meters per second. And after 2 seconds of fall, it would be going 20 meters per second. And after 3, it would be going 30 meters per second, and so on. And that works in both directions. If you throw a ball up into the air, it will lose 10 meters per second of speed for every 1 second of time. And if you drop it, it'll gain that same 10. When you combine the x and the y motions, the left to right and the up and down, you end up with a projectile, something that flies through the air, having both constant velocity in the x and gravity affecting it in the y direction. So headed this way, we have a constant velocity, and headed in the up and down direction, we have gravity, slowing it down on the way up and speeding it up on its way down. Now, the thing that I want you to understand is that what's happening in the x direction and what's happening in the y direction are completely independent of one another. They do not affect each other. So if you have something like a football that is kicked into the air, what is happening as it moves across your view from left to right does not affect how quickly or how slowly it goes up and down in the air. And the opposite is true as well. Gravity slowing that ball down as it goes up and speeding it up as it comes back down is not affecting how quickly that ball is moving in the x direction from left to right on your in your view here. So they do not affect each other. They are independent. So I want you to see if you can think about this and figure this out. If I had two objects, this green blob and this red blob, and at the very same instant I launched one of them, the red one, to the right. So it was launched off horizontally, and the green one was just dropped, simply dropped straight down. I want to know which one of these two things would hit the ground first. So think about that and come to class prepared with what your answer is and the reason why you think that's true.